are talking about problem solving today. Happy Friday, by the way. Problem solving. I know, me too. Next week is really busy with the HLC. So I had meeting after meeting after meeting yesterday. So it might have been why I forgot about meetings this morning. Mariah, I'm sorry. No, we talked it out. It's fine. But yeah, yesterday was meeting after meeting after meeting. So, okay. So the last time that we were here, we were talking about the fact that there are 4 different types of problems that we can deal with when we are dealing with problem solving. So we have a well-defined problem, an ill-defined problem. We have knowledge-rich problems and knowledge-lean problems. So make sure that you know all of those. So Ashton and Nicole, I know that you weren't here on Wednesday. So a well-defined problem is basically when we have all of the steps to solve a problem, they're all specified like a maze. So you have your initial state, your goal state, all possible strategies are already outlined for you. An ill-defined problem is when some of those things are unclear, like getting a flat tire in the middle of nowhere and your cell phone just died. In those cases, your initial state, your goal state, and your strategies to solve the problem are not clear. And then finally, knowledge-rich problems require a lot of background knowledge. So for example, designing a working memory experiment is a knowledge-rich problem. Brain surgery is a knowledge-rich problem. Knowledge-lean problems, though, do not require prior knowledge to be able to solve them. Playing tic-tac-toe would be a knowledge-lean problem. Bless you. And is everybody who was feeling a little under the weather earlier in the week feeling better? Y'all might want to get your flu shot. Flu's going up, and apparently the flu vaccine this year is a really good match for the strain that's circulating. So the flu is probably the sickest I've ever felt in my life. So I would not recommend. I got it when I was 13, never doing it again, if I can possibly avoid it. Okay, so I want to start with a real world problem, and I am going to pause screen sharing at some point because I want to show you a video. So I want you to imagine, and if you've read ahead, don't spoil. I want to show you, how many of you are familiar with the show Let's Make a Deal? Or have you ever heard of the show Let's Make a Deal? Is there anybody here who hasn't heard of Let's Make a Deal? Can somebody explain Let's Make a Deal to Ashton? So what's Let's Make a Deal? Yeah, Sarah.
So if I remember, I've never seen it, my mom has. If I remember, isn't it like thing where like you get like a suitcase, you open it, and it's like you get $500 and you can choose to keep that, or you could open up a different suitcase?
That's deal or no deal. That's deal or no deal. Anybody else heard of Let's Make a Deal? Wayne Brady used to host it, and it used to be a show back in the 70s. So the idea is that you would pick from 3 doors, and there would be a fabulous prize behind one. And then usually behind the other 2, there'd be some sort of gag prize. So back when I would go to my Grammys and watched Game Show Network, I would watch Let's Make a Deal because everybody wears like ridiculous costumes and stuff like that. And the gag prizes are things like you win a donkey, or you win a tree that has a bunch of shoes hanging off of it, like gag gifts like that. So here's what I want you to imagine right now. So I want you to imagine that behind this door, one of these doors, is a brand new car. Somebody name a car that they really want. How about a really fancy electric car? Since we're trying to focus on more sustainability. So let's say fabulous new electric car. I think my sister just got a Chevrolet Volt because she lives in California and they require electric vehicles. So she has a Volt. They're going to at some point.
Oh, I was like, oh.
They're going to, not yet, but they're about to. But yeah, she got a Chevy Volt. So I want you to imagine that a Chevy Volt is behind one of these doors, and behind the other doors are goats. Now, just as a friendly reminder, the goal is to win the car, not a goat. I would love a goat, but the goal is to win the car. So I'm going to go ahead and draw these doors. This is door number 1, door number 2, and door number 3. So somebody pick a door. Yeah, you pick 3? That's okay. Okay, so we picked 3. So here's what I'm gonna do. So what are your chances of winning the car right now? 1 out of 3. Fantastic. So I'm going to basically make things a little more interesting here. So I'm going to open up one of the doors that you didn't pick. So I'm going to open up door number 2 and look, oh gosh, you're going to get to see my terrible goat drawing. It's going to be great. Look, it's the worst goat Dr. Gilchrist ever drew. Okay. It's got horns and a little beard. It's fine. Here's rectangular pupils there. Now it looks worse. Okay, so we have a goat. So now here's my question for you. So here's the thing. I'm going to give you the option to switch to door number 1 or stay with your original choice of door number 3. So my question is, do you have better odds by switching? Do you have better odds by staying put with your original choice? Or does it matter? Does anybody have any thoughts? What should I do? Ashton?
I don't think it matters because now it's just a 50-50.
Is it 50-50 though? No.
Because in one there's a goat and in one there's a car.
Well, but this is interesting. So I'm going to be Morpheus for a minute. What if I told you that switching actually doubles your shot at winning? Okay, so let's kind of work through the math here because this is where it gets tricky. So everybody gets 1 and 3. Once I pull one of the doors out, though, all of a sudden people go, it's 50-50, right? So here's what we're going to do to solve this problem. And I'm going to show you why switching actually doubles your chances of actually winning. So generally, here's the thing. So let's kind of work through this right now. So we already know there's a goat behind here, but I want to work through some different probabilities for you. And then we're going to watch a video clip from the show Numbers that explains this in a slightly different way. I like to start by kind of mapping out reasoning and logic here. So here's door number 1, door number 2, door number 3, and then we're going to have switch versus stay. So here's how the situation could break down. So door number 1 could have the car, while door 2 and 3 have goats. Door number 2 could have the car, while the other 2 have goats. Or door number 3 could have the car, while the other 2 have goats. Now here's what's always going to happen. I am always, and by the way, let's go off of the option that you pick door number 3 every time. So this is what the outcome of probabilities could be. Now, I am never going to show you a door that doesn't have a goat behind it. I'm not going to be like, whoops, you picked the wrong one. Here's the car. Guess you're stuck with the goat. I am always going to show you one that has a goat. So you still have a chance to win the car. Like, I'm not evil here. I just like puzzles. So if you pick 3 and I show you door number 2 with the goat, if you switch, you win. If you stay, you lose. Here, it's under door number 2, so I'm going to open door number 1. Again, if you switch, you win. If you stay, you lose. If it's behind door number 3 and you pick 3, this is the only time where if you switch, you lose, but if you stay, you win. Because you have 1 in 3 odds, it's more likely that you picked a goat than a car, which means it's going to be to your benefit to switch. The odds of you winning if you stay are 1 out of 3. The odds if you switch are 2 out of 3. Can you kind of see how that works now? Now we're going to watch a clip from the show Numbers that explains this as well. How about that? They also do it in the movie 21, but I don't like Kevin Spacey, so we're not going to show that. Okay, so I'm going to resuming recording. Okay, so there are different ways that we can actually solve this problem. And I generally like to work through a variety of different possibilities. So when I hear that explanation in numbers, it doesn't necessarily become clear to me unless I'm doing something like this, where I'm actually using logic to reason through the different probabilities. So we're going to go back to the Gestaltists, and you might remember the Gestaltists from when we talked about visual perception. But did you also know that they did a lot of work with chimpanzees and with problem solving? All right. So the Gestaltists, when they talk about problem solving, they emphasize reproductive thinking versus productive thinking. You're not going to be able to get that with your quote. What even is? It was made out of clay. It looks like it was made out of clay or like plastic stuff.
Cobalt.
Huh?
Cobalt.
It's cobalt, really?
And you mix it with some other stuff that is mainly cobalt.
So the Gestaltists are all about reproductive thinking versus productive thinking. And in general, the Gestaltists were interested in productive thinking. So when we do reproductive thinking, we use our past experiences to help us solve a problem. But what's kind of critical for the Gestaltists is that sometimes you need to restructure a problem in a brand new way and represent the problem in a brand new way to be able to solve it. Yeah, so we need to think about a problem in a new way to be able to solve it. We need to change how the problem is represented in our minds. And this will include a few different things. So it will include solving problems on the basis of what we call insight. So having the solution suddenly pop into our head. It could include incubation, where we step away from a problem and then we come back to it at a later time after we have let our mind kind of work its way toward the solution. And then representational change, how the problem is actually represented. Okay, everybody good? It's very stuffy in here today. Okay, so I know that for some of you that have had general psychology with me, you have seen this before. Do not spoil it for anybody who hasn't, but here's what I'd like you to try to do. So we're going to take maybe about 2 or 3 minutes to try to work through this. So I have 6 matchsticks. What I'd like you to do is arrange the 6 matchsticks in such a way that you form 4 equilateral triangles. So just as a reminder from geometry, equilateral means that all of the triangle sides need to be of equal length. Okay, so go ahead and try to see if you can solve the problem. So work in your notes or on a scrap piece of paper for about maybe a minute or 2. And then if we need to give you a hint, I shall give you a hint. So just do your best. You're going to take those 6 matchsticks and form 4 equilateral triangles. Here's a hint. Don't break them. That's not going to work here. You are not allowed to break the matchsticks. You are also not allowed to eat the matchsticks. I was making a bad joke. Yes. Okay, so this is probably the most common one that I've seen. The only problem with this is that these 2 that are crossing in the middle would need to be longer than the rest of them, and that goes against equilateral. So it's a nice idea that works, yes. How so? I will come back to you. I will come back to you on that because it's not quite. Yeah. Is that? That's not gonna work. So I will kind of mention, just to kind of cut this off at the pass. So a very, very common one that we see, and this is where annotate will be really helpful. I like annotate. It's the one thing I miss about Zoom classes. So I've gotten some people who are like, okay, you put one matchstick this way, one matchstick this way. I'm not going to be very good at this because I'm using a mouse, but then you do that and then you put the other two like that. That's not going to work though, because these two in the center would have to be longer. Okay, let me take a look really quick and then I'll give you a hint if you need it. Not quite, not quite. I know that they have to be equal width. Maria, you probably remember this. Haley, how about you? Okay, I'm gonna give you a hint. I never said that they had to lay flat. Okay, well, I didn't know that. That's like, I can't tell from the way that you drew it if it was flat or not. Okay, but I'm sorry, Ashton. I'm sorry, I misunderstood you. Okay, did y'all get the answer now? Wait, you should get that. But yeah, so a lot of you got stuck because when the matchsticks lay flat, you assume that that's how they must lay. So once I say they don't have to be flat, that changes how you can present, how you can represent the problem in your mind. You were imposing a limitation on yourself that I never actually gave you. And so by telling you there isn't a limit here, that opens your mind to create that representational change. We're going to try another one now. Hello, this is the famous candle mounting problem from Dunker. And again, if you had me in Gen Psych, don't spoil. You are given a candle, a box of tacks, and a book of matches. Your goal is to attach the candle to the wall next to the table in such a way that wax will not drip on the table. So I would like you to try to draw a solution, please.
There's a whole box.
Okay, what do you mean? Yeah, Ashton.
Does the candle have to be lit? That was my question.
Yes, you have to light the candle. You do have to light the candle. And if y'all don't quit it, I'm gonna sing the Christmas candle song from Saturday Night Live. There's a candle, a random candle that you give your friend or something like that. So how is that being attached to the wall?
Have to get to the wall
Okay, so you're gonna have it just lay on a row of tacks.
with some matches in the wall.
Okay.
Near the wall.
So the way that the tacks are set up, though, so we're talking thumb tacks. The problem with that is that if the candle is bigger and wider than the tacks, it's not going to stay up there very well, even with the box of matches as a mount. Yes. Okay, let me see. Yes. Ashton, do you want to share what you got? Okay.
Empty the box of tacks out and tack the box to the wall and put the candle in the box.
Okay, those of you that did Gen Psych, how many of you remember that? Okay, how many of you were in Gen Psych and forgot that? It's okay if you did. How many of you got that though? Okay, now what tripped you up in this case? What tripped you up here? You didn't think that the box of tacks could be used for anything other than holding tacks, right? Actually, when I got this problem in my cognitive psychology class, if you want to have a laugh at my expense, I was like, take a thumbtack, nail it through the candle. That the thumbtack's not going to be thick enough for that. Every now and then I'll get somebody who's like, make an elaborate throne out of many thumbtacks. And I'm like, yes, but how are you going to attach the elaborate throne to the wall? And somebody's like, do you have to light the candle? Yes, because how will you prevent the wax from dripping?
Prevent it from dripping by not lighting.
Well, yeah, but you know what? Your residence hall doesn't care that you don't light a candle. It's all about the potential. Okay, so what is happening here is famously referred to as a problem of functional fixedness. So we get this case where we see the function of an object as being fixed and unchanging. Yeah, functional, I think it might, do I have it somewhere here? I don't. Oh, that's a bummer. Okay. I was like, do I have it somewhere here? I don't. So it's called functional fixedness. This is when we perceive the function of objects as being fixed and unchanging. Thus, a box of tacks can only be used for holding tacks and cannot be used for any other creative purpose. Drink from the opposite end of a glass. That's what my mom always says. And she had to explain to me how to do that because I'm like, but that's just this. Like, she's like, no, it's not. Okay. So when we have insight, so how many of you, when you experience the solution to that problem, you experienced it as like an aha experience, like, oh, there it is. That's how I fix the problem. That is what is referred to as insight. So insight is an experience of suddenly realizing how to solve a problem. Now, one of the things that the Gestaltists bring up is that when you have an insight problem, it's usually because you were stuck on something. You were stuck on representing the problem in a certain way or seeing the function of an object being for a very specific purpose. So when we reorganize how a problem is represented, that kind of breaks this block that we have, this period of being stuck, and thus we get that aha experience. And it's a really fun thing. No, it's not a bias. It's just a way to solve a problem. Insight is one particular way to solve a problem. You could argue that fixedness, like functional fixedness, could be a form of biasing the types of strategies that you use, but I would not say insight itself is a bias. I would say something like fixation or a functional fixation is. All right. So we are going to do an example here. So I'm going to give you 3 different words. And so here's the thing, I'm going to give, this is what's called a remote associate problem. So I'm going to give you 3 words. Each of them have another word that is in common with them that makes a compound word. So for example, if I give you the word bird, jack, and ball, they all have the word black in common because you can have black bird, black jack, black ball. Does that kind of make sense? So we have this other missing 3rd word, 4th word that makes a compound word from each of them. So I'm going to give these to you. So I want you to think of a word that goes with each of them to make a compound word. Are you ready? Yeah. Yeah, this can help you solve the problem. Okay, so it's card, master, and fence. Think of another word that goes with all 3 of these to make a compound word. So that's fence, card, and master. It doesn't have to be at the beginning. It could be at the end of the word. The example I gave, they were all at the beginning, but they don't have to be. So fence, card, and master. Okay, so I'll give you a minute to try to solve it on your own, and then I'll give you a hint. Okay, at least 2 of the compound words have to do with male. You got it? Oh, she had an insight experience. Look at that. You made the face and everything. You had the eureka moment. What is it?
Oh,
Yeah, fence post, postcard, postmaster. Kind of fun, huh? I like those kind of tests. They really get your brain working. But that's what's called a remote associates problem or a remote associates test. It's a really good way to look at insight. You look a little confused, Zoe. Can I help?
wouldn't this be similar to like chain reaction?
What is chain reaction? Is it a game? I've never heard of it. Can you tell me a little bit about it?
Like there's like 7 words and you get like a letter. You have to start from both sides.
Oh, is this a game that's on the Game Show Network as well?
Yes.
I've never seen it, but I've heard of it now that I think about it. Cool. Yeah, I think it is kind of like that. Okay, so we're going to try another one. So this is developed by Kaplan and Simon. This is what is called the mutilated draft board problem. So in this particular instance, what we are going to do, so this is a mutilated draft board. So I've basically given you a chessboard or a checkerboard, and I've removed 2 corner squares. So my question is, so normally this board would have 64 squares. Right now it has 62. Here's my question. Can the remaining 62 squares be filled with 31 dominoes such that each domino covers 1 white square and 1 black square? Now, how would you normally want to go about solving this problem? Most people would try it with dominoes and actually try to fit them all over the board. But you don't actually need to do that here. So here's a simple thinking strategy for you. What color squares am I missing? So here's the thing. I'm not missing a black square and a white square. I'm missing 2 black squares, which means there are more white squares on this board than black squares, which means there is no way that I can fill that with dominoes and cover the board with dominoes such that 1 white square and 1 black square is covered by the dominoes. I've already removed 2 from the board. It's not possible. So most people will try to cover it with dominoes, but if you stop and think about it in a very different way, you get an easier means of solving a problem, and also you don't throw dominoes everywhere. All right. So it turns out that animals can also use insight. The Gestaltists were actually very interested in how subtle hints could be used to facilitate insight problems. So notice that just by giving y'all a hint about that remote associates test, it helped you figure it out on your own. Subtle hints can be useful here. So the Gestaltists, so Kohler, Kafka, and Wertheimer looked at chimps, including this chimp by the name of Sultan. So he was put in a cage with a banana and 2 sticks. Obviously, he is a chimp. His goal is to get that banana because fruit is delicious and very reinforcing for chimps. So when researchers actually walked into this space and put together the sticks by accident, the ape was much more likely to reach the solution than if that hint had not occurred. In another case, Kohler actually had bananas hanging on the ceiling of a cage. And then there were, obviously the ceiling was going to be too high for the chimp to actually reach the bananas. But there were boxes that were scattered around that could be used to actually reach the banana, particularly if you stacked them. And so Kohler actually noted that they would try to jump for the bananas at first, and obviously they'd get really ticked off. You generally don't want to deprive an animal of its food. It gets very angry. But then Kohler kind of reported that the chimp basically sat down and they looked like they were thinking. So they kind of did the whole thinker thing, like Auguste Rodin. And basically, they got an aha experience and then started stacking the boxes to actually reach the banana. So animals can also use insight, and this insight can be facilitated by subtle hints. So you might be asking yourself, is insight an actual real thing? And this is something that Janet Metcalf and Weiba actually looked at in 1987. So one of the ways that we can measure insight is with something called a feeling of warmth. So how many of you have had an instance where you've kind of hidden something from your friend or your family member and you kind of want them to go find it? And so you play like the hot and cold game, like, oh, you're hot, you're getting closer, you're warmer, you're warmer. Basically think about that, but think about that in relationship to how you are solving a problem. So here's what's really interesting. So I'm going to kind of map this out for you here. So here's your feeling of warmth. And here's what's happening over time. So insight problems are really, really interesting. Warmth stays really low until about right before you solve the problem, and then it suddenly spikes. So it's basically, I don't know, oh my gosh, I know. Now, this is what happens with an insight problem. On the other hand, think about a problem like a math problem, like a trigonometry problem, where you have the different formulas and the different strategies that you need to solve the problem. You're just going to progressively get there in a series of steps. So this would not be a problem that involves insight. And what we find is that the feeling of warmth for non-insight problems looks really different. Basically, with a non-insight problem, the closer that you get to the solution, the increased your feeling of warmth becomes. And they actually did test this with the Remotes Associates test, much like the one that I gave you. And we already kind of went through this. But sorry, we'll talk about brain areas involved in insight in a minute. But yeah, now you can share this little trick with your friends. Or puzzle with your friends. Don't trick your friends, like don't prank your friends with puzzles, just share them because you want. Just share them, it's fine. Actually, you want a cool trick to share with your friends that I haven't demonstrated here yet? I need somebody who's never tried this before, so anybody want to be a willing participant in this? Okay, Sarah, I've never done this with you. Okay, spell joke. J-O-K-E. Spell poke. P-O-K-E. Spell smoke. S-M-O-K-E. Did we already have spell spoke? Okay, spell spoke. S-P-O-K. Spell toke. T-O-K-E. What's a white part of egg? What's a white part of an egg? But you know what most people will do when you do that? When you go oak, 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 you set them up to say yolk. So you caught yourself, and it's partially because I stumbled over that question, but I did actually try that in Gen Psych the other day, and somebody was like, it's the yolk. I'm like, it is not, it is the white. The white part of an egg is called the white. So yeah, but your brain really wants to say the yolk, doesn't it? You got to fight it a little bit. So that's something that's called cue bias. So I basically bias your cues in such a way to give you an answer that is incorrect. Try it with your friends. It's a fun little trick. It's like one of those ones that they would give you when you were a kid where they're like, what are the colors of the American flag? And you're like, red, white, and blue. And isn't a color, like those kind of ones. Yeah. All right.
They say silk 7 times fast and what do cows drink for milk?
I mean, technically, yes, when they're babies. Yes, I know. We're being technical. All right, are we good here? Okay. So let's talk a little bit about the brain areas that are involved in insight as well. So researchers have actually found that for problems that require the use of insight, the right hemisphere tends to be more involved than the left. And researchers have argued that this is because you are looking for the semantic relationships between different types of words. Additionally, there is another part of the brain that sits directly underneath the frontal lobe called the anterior cingulate cortex. Now, the anterior cingulate cortex often gets involved when there's conflict between responses. So in that example that I gave Sarah, if you're torn between answering yolk and the white, your anterior cingulate cortex is going to be pretty active at that point because it's monitoring conflict. And oftentimes we're going to find that the reason that insight problems happen is because you are organizing something in a new way. So the anterior cingulate cortex is going to be monitoring potential conflict between your old ways of solving the problem and the new ways of representing the problem. Right, everybody good? Well, your pen's still wiggling. I want to be careful that I don't rush. All right, we got 5 minutes left to your Friday. Woo! Okay, maybe I'm the only one that's excited. It's fine. Okay, so one of the things that we're going to find to help insight to happen is that hints are often very useful. And it doesn't have to be an obvious hint. It can be a subtle hint. So we are going to look at what is referred to as the pendulum problem. All right, are you ready to take a look at this? I will wait until you are done writing, but we're going to finish up by talking about the pendulum problem today. All right. So here's the pendulum problem. So the idea behind the pendulum problem is that you have to tie these two different strings together. So what you're going to need to do, you are in this room, you've got two strings that are too apart to tie together. You also have a chair and you have a pair of pliers. Does anybody know how to solve this problem? Any thoughts? How do we solve this problem? Ashton, you want to give it a shot?
Are you allowed to rip one of them out of the ceiling?
You are not allowed to rip one of them out of the ceiling. They got to stay put.
Touching.
They do have to be touching for you to be able to tie them.
So you have to tie them to each other?
Yeah.
Are you allowed to let go of one of the strings?
Yes.
So move the chair to the center of the room and take the strings.
You're not going to be far. They're going to be too far for you to tie them with your hands. Okay. We've got a pair of pliers here. What do you think you could do with the pliers?
Hold them together while you tie them?
Okay. Maybe we can't hold them, but what can we do? It's called a pendulum problem. What's our pendulum here? You got it, Zoe?
Yes, you have them on like the pliers hold them.
Okay, so you're kind of going in the right direction. That's not quite what I'm looking for this problem, but I think you're getting in the right direction. Do you want me to tell you the answer? You tie the pliers to one string, swing it like a pendulum, then you're able to catch it and tie them. That's basically the whole point. But here's what's kind of interesting. That's really hard to figure out if you're not physically in the room and you can't try it for yourself. So when you see a visual of it, it's kind of hard to grasp. But generally, so the idea is you swing it and then catch it on the upswing, and then you can tie them at that point. So here's what's interesting. So it turns out a really subtle hint can facilitate you thinking of using that string like a pendulum. So here's how they did it. So a couple of researchers, Thomas and Laris, back in 2009, actually had people try to physically solve the problem with this setup, but they would take exercise breaks. And here's what's really critical. One group were told to swing their arms like this, getting you in that pendulum mindset. The others were stretching. The group that was told to swing their arms were more likely to solve the pendulum problem than people that were just stretching their arms. It's almost like getting in that swinging motion makes you think about the ability that these strings can swing. And this is pretty subtle. Most of these people did not get the relationship between their arm movements and the solution to the problem. They didn't see that relationship. So even subtle hints that we are not aware of can help us solve this problem. So I'm going to go ahead and stop here. Next time, oh my gosh, we did have a slide for functional fixedness. Okay, well, you'll have another definition. Next time, we will talk about incubation and why some of your best ideas tend to pop up while you're taking a shower. All mine do. All of my best research ideas happen in the shower.